Our quiz for today is to use special products, expand this and this. Now, what are our special products? We should know at this point because your homework has used them again and again. However, most people don't remember what all the special products are. When you do these problems, you should be writing out the special product on paper and connecting it with the expression. Otherwise, you're going to have some trouble with what we have to do this week. So make sure you understand what I'm talking about. So, for example, three x minus four y quantity squared is of the form a plus b squared, where a would be three x and b equals negative four y. A plus b quantity squared equals a squared plus two ab plus b squared. Now you should be able to write out a plus b times a plus b and get this, that this is a form you simply have to recognize, and you simply have to get it in your head that that's what this equals. And if you need to multiply this out every time, well, that reminds you what you do. But after you've done that a couple of times, you know why this equals this. If you're just writing down the answers without connecting it to the special product, if that's what you did when you did your homework, then you aren't sufficiently connected to the special product. Okay? And especially if you had the special product sitting in front of you while you did your homework, you didn't learn this as well as you could have, even though everybody is pretty much getting the right answers in these, maybe with a little bit of error here and there, using the distributive law, which is what we've learned. Okay, and that looks pretty good. What I don't see looks pretty good is you really know the special products and how to apply them. Okay. And I suspect that people take the shortcut of having the thing in front of them rather than remembering it every time, bringing it out of memory. If you don't bring it out of memory, every time you do these, after a while, you do a couple of problems with the special product sitting there, then you start making yourself remember, and you come back the next day and make yourself remember. That's how you learn the special product and how to apply it. That's just advice on how to go about homework. Don't have a lot of aids in front of you. By the time you get to your homework, make sure you know everything. And if you don't, well, then, yeah, go back and look. But get to the point where you can do the second half of your homework without having to look at anything. Pretty much. I mean, you're still going to have to take a peek every once in a while, but for a test, you're going to have to know this, and you have to prepare yourself for a test or a quiz when you do the homework. Okay. So what I'm saying today, I saw people write out the correct product here. I know they didn't do the distributive law in their heads, and if they did, that's great. Okay. So you've got the pattern down, but reinforce the pattern by writing out the distributive law. That's what I'm, or by writing out special product. And if you have the special product written out and you've identified what A is and what B is, then you just write out whatever A is squared, and then 2 times whatever A is times whatever B is, and then the square of B, whatever B is. Right there it is. Okay. Now, square of 3x, I'm going to be really complete about this. It's 3 squared times x squared plus 2 times 3y times negative 4y is negative 12, and that should be 3x, not 3y, negative 12xy. And then plus 16 times negative 4 squared times y squared. And this is an intermediate step that you really don't need, but it's a good idea to write it out because you simply need to reinforce the fact that sometimes something squared is the square of this and times the square of that, and so forth. Okay, anyhow, this gives you 9x squared, it gives you minus 24xy. I saw people that had negative 12xy there. Okay, well, if you'd have written down the formula, you would have gotten the negative 24. And I saw that with the negative 12 is pretty much written down by understanding the pattern or knowing what the pattern is, but there's a little bit of an error in there. And nobody here today, and nobody in general, after doing this homework, knows it well enough to get away without going through these details. Again, if you go through the details, you learn it better, you get it right, and you prepare yourself for the future when you're going to be tested over this, and when you're going to have to be able to recognize this form when you see it. Okay? So that's just advice again. I've repeated it a couple of times, but so be it. Okay, so what about this 5x minus 3y times 5x plus 3y? Now, I noticed my open math assignment didn't ask you to do any of these. Of course, we went over it last time, so you really need to know what the special product is, because again, we're going to be using it. Turns out that it's a lot easier to recognize than this one, and we'll see what I mean by that shortly. Okay, well, this is a minus b times a plus b, with a equal to 5y and b equal to 3. A is 5x, sorry, and b is 3y. There's your a, there's your b. Now, a minus b times a plus b equals a squared minus b squared. So, so this is a squared minus b squared with a equal to this and b equal to this. And that's nothing but 5x squared minus 3y squared. And I'm not going to belabor the intermediate step here where you write 5 squared times x squared, but it's a good idea to do that. And then you get down to this, and this is equal then to the original form. And that's a lot quicker than the distributive law, although the distributive law works just fine if you're careful. So the point is not so much that you can square this thing, although it's handy to be able to do that, or that you can do the product of a difference in a sum of 2 terms, but so that you recognize these forms. So what I want to do now is just ask you to see if you can identify which of the expressions I write up here are of the form a squared plus 2ab plus b squared, or a squared minus b squared. Now, I'm kind of box these off, and I'm going to put this off where it's not on camera, but you'll be able to see it. Reference. So I'm just going to write down some expressions. Okay. Here. I'll give you a hint for the start. This is of the first form. Can you identify A and B? This is the second form. Can you identify A and B? Okay. So it'll be easiest with this one, but once you've seen what A and B are here, it'll be pretty easy to identify it up here too. Okay. Okay. People did pretty well with this. Okay, so we've got so this equals A squared minus B squared. Now I'm going to go ahead and write this out. This might or might not be helpful, but this is the way you saw it when you got it, and everybody got this. Okay. 16x squared should be A squared. Now, everybody said so A equals 4x. And that works just fine for this. Okay. But of course, A could be plus or minus 4x. Because if A was negative 4x, A squared would still be 16x squared, wouldn't it? So you don't know whether A is supposed to be plus 4x or minus 4x. And sometimes that makes a difference. And B would be possibly plus or minus 6y. Okay, so this is A minus B squared, and we've identified A and B and chosen to use plus 4x and plus 6y. So if this equals this, since A squared minus B squared equals A plus B times A minus B. Okay. Now it's your choice whether you put the minus here and the plus here, or the plus here and the minus here. Okay. You can write it either way. And actually I wrote it one way over here and wrote it the other way here. But simply, it's what you get when you got a plus here, plus in one of them and a minus on the other. Okay. So that works. Okay. Let's try. I'm going to write this out as a question. Is this expression of the form A plus B quantity squared? Okay. If so, then A plus B quantity squared is A squared plus 2AB plus B squared. If so, A squared equals 4x squared, B squared equals 9y squared. Choosing to use A equals 2x and B equals 3y. Maybe I should choose to use the right one first. I'm debating. Okay. If I use A equals 2x and B equals 3y, then 2AB is not going to equal negative 12xy, is it? If we chose 2x and 3y, remember we could choose the plus or minus on either of these, okay? Well, xy doesn't match negative 12y in the original expression. Okay, so this is different than what we had in the original expression. Well, if you plug A equals 3x and B equals negative 3y into A squared plus 2AB plus B squared, this is going to equal the square of 2x plus 2 times 2x times negative 3y plus the square of negative 3y. And that equals what we wanted to equal. That's 4x squared minus 12xy plus 9y squared. Okay? And that checks out. Now I'm going to write a few more of these. These are pretty obvious. If it's a difference of two squares, if it's a difference, and you can easily find something that whose square equals this, and something whose square equals this, it works out, right? And you can choose the plus or the minus on either one. So you have actually several choices for A and B. The first form pretty well dictates what you get. So let's try 16x squared plus 20xy plus 4y squared. And then let's try 9x squared plus 16y squared minus 14xy and then I'll throw one of the other ones in that's just a little more complicated. Try that one, see if we get anywhere with it. Okay. Let's start with now we can see that A should be 4x and B should be 2y. We pretty quickly learned to recognize what A and B ought to be. Everybody's got that right. Okay. Save this. Okay. Now, if A equals 4x, then A squared equals 16x squared. And if B equals 2y, then B squared is 4y squared. So I'm not going to bother to write that out. I'm just going to put a little check mark on the 16x squared and the 2y squared. And we then have to check your 2ab should then equal 20xy. If the form is perfect square. But 2AB in this case is 2 times 4x times 2y, which is 16xy. So this is not of the form so it isn't so. What isn't so? The form is this. This condition is not so. Everything matches, but there's no way that your 2AB is going to give you a coefficient of 20. Now, on the other hand, for 9x squared minus 14xy, A would have to be plus or minus 3x. B would be plus or minus 4y. Now, using A equals 3x, B equals negative 4y, you see you have a negative 14xy here. So we conclude that this expression is not of the form A plus B quantity squared. Now, this is of the form A squared minus B squared. If A equals 3x squared y. Because if we square A, 3 squared gives us 9. You square x squared, you get x to the fourth, and you square y, you get y squared. And B equals 2x, because if you square 2x, you get 4x squared. I need to write that out the way I did. And this is just an instance of a squared minus b squared equals a minus b times a plus b. Okay, so make sure you understand the logic of that. Now I'll do an example. Let's say we have this. Now, this isn't a perfect square. And this isn't a perfect square. But we notice that all our coefficients are multiples of 5. So we can write this as 5 times x squared minus 2xy plus y squared. And now, I'm not going to go through the details. But this is 5 times x squared, times x minus y squared. So by expressing this as 5 multiplied by another expression, we see that this expression can be factored so that we can write the original expression in this form. What we've done from here to here is called factoring out of 5. So I'm going to say factoring out 5 gives us this. Another example. Let's say we've got 4x to the 4th, y to the 6th. Minus 20 times something. I'm going to get my last one here. That's too complicated. I can't make that one up in my head in a way that I'm confident is going to work out. I should have worked that out before I started. Let's just take the expression. Let's just take this expression here. Now, this is not going to factor using one of these rules. But one thing we can see is that every term here contains x squared y cubed. Okay? In other words, there's an x squared in this one because there's an x to the 5th, right? And there's a y cubed in this one because you have a y to the 7th. And you got an x squared in this one, and you got a y cubed in this one. So what we can write out is x squared y cubed Now, what would we have to multiply by x squared y cubed in order to get 5x to the 5th y to the 7th? Well, we're going to need a 5 because we don't have 5 here. Now, x to the 5th already has an x squared, but then it has an x cubed. Okay, so x to the 5th could be written as an x squared times an x cubed, meaning if you divide x to the 5th by x squared, you get x cubed. Y to the 7th already has a y to the 3rd. It needs another y to the 4th. Now, if I multiply these out, x squared times x cubed gives me x to the 5th. And y cubed times y to the 4th gives me y to the 7th. Because when we multiply, we add exponents. Another way of saying that is if I divide x to the 5th by x squared, I get x cubed. If I divide y to the, because x to the 5th divided by x squared is x to the 5 minus 2, which is x cubed. And y to the 7th divided by y cubed is y to the 7 minus 3, which is y to the 4th. So in two ways, we can understand that this times this is going to equal this. In other words, yeah, okay. Anyhow, then we have just need plus 3 here because we've already got our x squared y cubed. And then for this one, we got x to the 4th. We need another x squared. We got an x y to the 8th. We have a y cubed here. That means we still need y to the 5th here. Now I recommend we check this. If we multiply this out, we have x squared y cubed multiplied by this, plus x squared y cubed multiplied by this. And we have x squared y cubed multiplied by this last term. We can multiply the individual terms out. We have an x squared times an x cubed. We have a y cubed times a y to the 4th. This second term can just be written 3x squared y squared. And this last term is, well, we have an 8. We usually put our number out in front. First chance we get. And we have an x squared times an x squared. And a y cubed times y to the 5th. Well, x squared times x cubed is x to the 5th. Y cubed times y to the 4th is y to the 7th. And we still have our 3x squared y squared. Then our 8, x squared times x squared is x to the 4th. Y cubed times y to the 5th is y to the 8th. This matches this. This term matches this term, except when I wrote out this term, I should have written a y cubed, right? I'm careless and wrote a y squared. So when I checked it, I said, wait a minute, this doesn't match this. I had a y squared here and a y cubed here. Then I went back and found where I made the error. I was okay here, but then I just didn't copy the y cubed down correctly. But now it's okay. Now, we have a 5x to the 5th y to the 7th, which matches the 5x to the 5th y to the 7th in the original expression. I'm going to ask you to do something similar. Now, we're not gonna try to go back and apply a special product to this because it just isn't gonna work. Let's try this one, it's a little easier. Try this one. I just realized that 4 was gonna work, but make that an 18. Okay, now, everybody, that might give a little help. 8 and 18 are both divisible by 2, so we're gonna have a 2 that'll divide both of these. Our lowest power of x is the cube. So we can factor out an x cubed. Our lowest power of y is y to the 4th. We can factor that out. Now, what are we left with? Well, we need to multiply this by something to get 8x cubed y to the 5th. Well, we multiply 2 by 4 to get 8. We already have an x cubed, so we don't need an x here. We need a y to the 5th. We've only got y to the 4th, so we need a y. Over here, we're going to need -9, since 2 times -9 gives us -18. And we have x cubed y to the 4th already, so that's all we need. So there it is. And if you do the distributive law, this times this, minus this times this, it's going to work out. So you want to check it. Make sure you do all those steps so that you retain everything well.